in memory. Of course, there is the executable of the kernel, but once the operating system is loaded, there is a function in the bootloader which removes the kernel symbol from the dev mem. So we cannot read the link edit section which contains the symbols. So what we have to do is to first get the executable or to read the link edit sections directly from the executable and not from the memory dump. So in symbols, we can retrieve the name of not exported variables, but the name of local variables, but also the name of functions on their offsets. Once we have the name on the offset of each variables or functions we are looking for, we need a kind of quick formula to do a conversion between the virtual address and the physical address. We have not set the kernel memory manager yet, so that's why we need a so-called quick formula. On Windows, you probably know it. You have to use a mask to do that. On Linux, you have to subtract a specific value. But on Mac OS, it's pretty easy. This is exactly the same thing. So the quick formula is really, really quick and really simple. So because this is a quick formula, it only works with the kernel executable. So, for instance, if we have the address of an allocated buffer, it won't work. That's why we need to set the kernel memory manager. So, anyway, what we need are some, like, one variable from the data section to set the kernel memory manager. So, here are the variables we are looking for, which are local variables in the data section. So at this part, you are really lucky because, for instance, if you take Windows, these variables are not set as local variables, but they do it on Mac OS X, so we are pretty lucky. So these variables are used by the memory manager. They are set during the booting process to set up the virtual address space which is going to be used by the operating system. So some people may use the PLM4 mode. Anyone? Okay. So the PLM4 mode is mainly used on a 64-bit processor to manage more than 64 gigabytes of memory. So on 32-bit processor, you have like the PAD mode, which allows you to use up to 64 gigabytes of memory. But on 64-bit processor, you are allowed to use more than this. So I will explain in the next slide why. So anyway, even on 32-bit operating system, this variable is set up. So we are going to use it. So it makes this method more reliable because we don't have to take care of the PAE mode or whatever. So there are people in this room who know how the physical, virtual to physical translation works. One person, cool. Okay, basically you have the virtual address attached with the PLM4 mode. You split it in 5 parts. On each part of the virtual address is an index for each table. So the first table we are going to use is the PLM4 table, which is the most extended table. So from this table, we use the first index, and we got a pointer to the next table, etc., etc. So it's not really funny to explain, so I'm going to skip this part. But anyway, you have the virtual address, which is split in 5 parts. So now, from this part, we have the kernel symbols plus the memory manager, which is initialized. So, do you remember what is the first step? No? So, from now, we can browse the full kernel address space. So, it means that devman is now devkmm. So, from this, we can now have access to allocated buffers by the kernel or even by user-owned applications, because we don't have the limitation we had before, that which was we were only able to read the data section on the text section. So now we can browse everything. And from this part, it starts to become more meaningful. So once again, there is a closure. Now we have access to devman. We can now retrieve all this information. So I'm going to start with machine information. Machine information are defined by 2 variables. These variables are from the kernel symbols, like the version, which contains a string with the exact version. The machine underscore info, which is a structure which contains very different information, like the major OS version, the minor OS version, this kind of stuff.